Hi, welcome back to Little Moles. Today, we will be talking about the two main classifications of hydrocarbons, aliphatic and aromatic. But before we discuss and elaborate on these classifications, we will first define what hydrocarbons are. Hydrocarbons are generally defined as organic compounds containing hydrogen and carbon atoms in its structure. Hydrocarbons, as stated earlier, can be classified into two broad classes, aliphatic and aromatic. First, we will talk about aliphatic compounds. Aliphatic compounds are compounds containing carbon and hydrogen, which may contain single, double, or triple bonds. These compounds can be further classified based on their structure and saturation. In terms of structure, aliphatic compounds can be classified into two, open chain and alicyclic. Open chain aliphatic compounds are compounds drawn in a straight chain and does not form a ring or figure. These compounds can be divided into two different types, straight chain and branched chain. Straight chains are those that do not have alkyl or substituent groups attached to the carbons in the parent chain. These compounds are generally the parent chain and is named as such in line with the prefixes set by the International Union of Pure and Applied Chemistry. Some examples of this are propane, propene, propyne, butane, and pentane. Branched chains, on the other hand, are those that have alkyl or substituent groups attached to the carbon in the parent chain. In naming these compounds, the alkyl groups are placed as a prefix to the parent chain's name, such as methyl, ethyl, propyl, and etc. Some examples of this are 1-methylpropane, 2-methylprop-1-ene, 2,4-diethylheptane, and 2-propylpentane. Next, let's move on to alicyclic aliphatic compounds. Alicyclic aliphatic compounds are compounds that contain one or more all-carbon rings which form a closed figure, but do not have aromatic character. These compounds may or may not have attached alkyl or substituent groups. In naming these compounds, the prefix cyclo is attached to the name of the parent chain. Some examples of this are cyclohexane, cyclopentane, methylcyclobutane, 2-ethylcyclopent-1-ene, and cyclohexane. Aliphatic compounds can also be classified based on their saturation. There are two types, saturated and unsaturated. Saturated aliphatic compounds are compounds whose carbons are joined by single bonds only. These compounds are also known as alkanes. In naming these compounds, the parent chain is attached with the suffix -ane and is named depending on the prefixes by the IUPAC. These compounds may or may not have attached carbons or alkyl or substituent groups in its parent chain. Some examples include hexane, methylbutane, cyclopentane, propane, and ethane. Unsaturated aliphatic compounds are compounds whose carbons are joined by either double or triple bonds. Compounds with at least one double bond are called alkenes, while those with at least one triple bond are called alkynes. In naming alkenes, the suffix -ene or -ene is attached to the parent chain, while for alkynes, the suffix -yne or -ine is attached to the parent chain, wherein the chain is named depending on the prefixes set by the IUPAC. Some examples include hexene, methylbutene, cyclopentine, propyne, but3-en-1-ine. Now, let's move to the next broad class of hydrocarbons, which is aromatic compounds. Aromatic compounds are hydrocarbon ring structures that consist of a benzene ring, wherein there are 6 carbon atoms bonded by alternating single and double bonds. This can also be drawn as a circle in the middle of the 6 carbon atom ring. These compounds are unsaturated, stable, and are known for their fragrant properties, hence their name. Alkyl or substituent groups may attach to the carbons in the ring. In naming these compounds, the alkyl groups serve as the prefix ending in -il or -yl, while benzene serves as the suffix. Some examples of this are benzene, methylbenzene, ethylbenzene, propylbenzene, and butylbenzene. To summarize this content, here's a diagram on the general overview of these classes. Thanks for listening. That's all for today on little moles, aliphatic, and aromatic hydrocarbons.